All right, in example number 3 here, we have what looks like just one triangle, but there's actually a small triangle inside of the large triangle. Okay, so we have this large right angle triangle here, and then we have this smaller right angle triangle, which is inside of there. And we're being asked to find what is this length right here. We're going to put a little question mark there. So what is P? The distance from here to here. Okay, now this, and I'm just going to shade it in again, is not a right angle triangle. So we can't use the 3 sides, so to speak, and say this is the adjacent opposite hypotenuse. That's not correct. It does not work because this is not a right angle triangle. But this large one definitely is. So what we're going to have to do for this question here, and I'm just going to put it into a different color, is we need to find what this length is, okay, which we can do with this small right angle triangle. I'm going to shade that in green. And then we're going to have to find what this entire length is, and then subtract the 2. Okay, so we take this long length minus the short length, and that will give us what is missing with P there. So I'm going to put a couple letters on here. I'm going to call this Z, and I'm going to call this one here X. Okay, so we're going to find X and Z, and that'll give us P. So just as a little bit of a heads up here, we're going to find that P is equal to Z minus X, and we have to find what X and Z are first. Now the order doesn't matter. We can do either or, depending on what you would like, really. And so let's start with X. And I'm going to use my green to represent X there. With X, this is 48, so this is our adjacent side, this is our opposite side, and this is our hypotenuse right there. Now the hypotenuse doesn't matter. We don't find the hypotenuse ever in these cases here. Okay, that happens way too often. But we want to find what the adjacent side is. So tan of our angle is equal to opposite over adjacent. And that means that tan of 48 degrees is equal to our opposite side, 12.8 meters, over our adjacent, which we are calling X. And if we solve this here, just like we know how to do, 12.8 divided by tan of 48, sorry, I should have put that over 1. We're going to get a length of 11.53 meters. Now, if we can keep as many decimal places as possible, that's awesome. This question is a little bit more difficult to do that. And so in this case here, we may just have to leave it just as 2 decimals. Okay? Just sometimes the way that it works out. All right, next step, we want to find Z. Okay, and we're going to do this in a very similar way. In this case here, we know that Z is our adjacent side. 12.8 is now our opposite, and this is our hypotenuse. This is our opposite. This long side is going to be our adjacent. And so tan of our angle, again, is opposite over adjacent. And now we're using a different angle of 28 degrees. And our opposite is actually exactly the same as the previous one, over the adjacent, which we're calling Z. Put that over 1. And now to find Z, we do 12.8 divided by tan of 28. And that gives us 24.07 meters. So once we have these two here, so that's short one, long one, to find P, we need to subtract. So to find P up here, we're going to take the long one, 24.07 meters, and we're going to subtract the short one, 11.53 meters. Okay, as we can't really get a negative length, so 24.07 minus 11.53 is going to give us a length of 12.54 meters. And that is the answer that we're trying to find. So we're trying to figure out P right here, find both of these lengths, and then figure out what P is as a final.